Hello, there we go.
All right, Laura, over to you.
Thank you. And thanks for your patience as we just get the mic handover started. So while I wait for my lovely speakers to be mic'd up, I will just get us started and help set a little bit of context for the next session here today. So this session is to explore the UK's role in semiconductors against the backdrop of an uncertain global market, potentially even more uncertain after yesterday. So semiconductors are in everything that we use, whether that is the phone that I've got in my hand right now, the lampposts outside, the cars that we drive, all the way to the computers that are pioneering some world-leading medical research here in the UK. But the supply chain that goes into building semiconductors is incredibly international and complex and interdependent. What that means is that if there's ever a global supply chain shortage, we end up in a situation where entire markets can be disrupted. And in 2021, we saw a global supply chain disruption that affected GDP by 1%. So that's quite significant. Therefore, the UK can't afford to miss the boat when it comes to semiconductors, but we need to work together as an industry to establish what actually is the UK's place in this global market. And that is what the panel is here to discuss. And if you were to look at that, I'm starting to have the panelists arrive on stage. So as we just wait for the final panelist to join us, and then we can get started. Perfect. I will move up. Okay, so let's start by maybe positioning that global supply chain that I just described when it came to semiconductors. Seems like a simple question, but let's get started by discussing why is the global semiconductor supply chain so complex, and where does the UK sit within this? And I'm going to ask everyone this question so you can all share your own perspective. If at that time you want to introduce yourself, that would be amazing. So Andy, we'll start with you.
Thanks, Laura. Andy Sellers. So I'm Operations Director with Silicon Catalyst. Before that, I set up the Compound Semiconductor Applications Catapult, built a team of about 100 people. And before that, I was at Innovate UK launching funding competition for semiconductors. Why is the semiconductor industry so complex and the supply chain so complex? I think the reason is the semiconductor industry has been around for about 50 years. And what has happened over the last 30 or 40 years is a large amount of specialization. So the UK has specialized in design, the US in design to a certain extent, in silicon semiconductors. The fabrication of those semiconductors has by and large migrated to the Far East. And the reason behind that is economics. It's economies of scale. You only really need one fab. For silicon semiconductors, you only really need one fab to make the global supply of the highest end silicon semiconductors. And then the tools to make those semiconductors have been developed in the Netherlands. So there's been this high degree of specialization. Now, what that doesn't cover is that semiconductors are actually quite complex. There are multiple materials. So the majority of semiconductors are silicon semiconductors. The brain in your mobile phone is a silicon semiconductor, but there are other types. So the display on your mobile phone is a large area semiconductor. The Wi-Fi and the facial recognition is a third type, a compound semiconductor. That makes it even more complex. But that's I think that's the fundamental reason why there's been specialization, and different countries have tended to specialize in different areas.
Exactly, and so we're kind of lumping together this big classification of technology and also different specialisms within that. So Peter, I think that might come to your point.
Yeah, thank you very much. So hi everyone, my name is Peter Stevens. So I'm Director of Government Partnerships for the UK at ARM, ARM. Sounds like I'm hesitating every time I say it. And so ARM is a UK-based, Cambridge-based company which designs IP and architecture, which is found in many of the world's semiconductors. I imagine that if you have a smartphone in your hand pocket, or if you're very well behaved in your bag, there's an ARM chip in it somewhere. So I think in terms of the question about the specialism, I completely agree with Andy's points about sort of the level of degree of specialism, the complexity, the economies of scale. My background is within tech policy, so I was in DCIT, or back when it was DCMS. We're looking at cybersecurity policy for a number of years, and then also at the OECD. And I think, as I'm relatively new to the world of semiconductors, like the level of complexity, the level of cost associated with it is kind of mind-boggling. I think there's this assumption that just because semiconductors are very, very small, that they're simple, whereas actually they're unbelievably complicated and very, very expensive. So, like, you know, figures that get banded around saying, you know, how much does it cost to make the most high-end fab that Andy talked about before? It's sort of order of magnitude of like $20 to $40 billion, which is, you know, an extraordinary amount of money. So when you think about that level of cost, the level of complexity, this is why we're starting to see so much specialism. When I think the UK does have real speciality, and I think design is one of the areas where there is that specialty, as well as compound as well. And I know that it's one of those things that we, you know, as we talk about the strategy, which I will come into, you know, a lot of that thinking about how can we really play to those strengths. And so, yeah, I'll pass to Eva in that case.
Oh, so a lovely segue, as if it was all planned. Yeah, hello everybody. I'm Eva Didashenko. I head up the Semiconductor Growth Team in Department for Science, Innovation and Technology. You will have heard from Minister Valens earlier today already. It's really exciting times, and I think the creation of this department has just been so much of a no-brainer in really bringing together the science and tech community in one place. My background is in lots of different tech policies. I've led on areas like internet encryption to cybersecurity to online safety issues, so a really wide range. And now sort of like to think that I've gone sort of from all the software levels all the way down to the hardware stack and reached semiconductors. And yeah, I mean, perfect segue. Really wanted to highlight some of the great strength that the UK has and how government has really recognised that, and not least in the National Semiconductor Strategy published last year. Design, obviously, as we just heard, is a massive one. Don't want to underestimate the role of ARM, but also the wider design community and also smaller companies that are coming in this space. But there are other areas, and I don't think necessarily that the strategy has sort of covered them all in a huge amount of detail. So when it comes to sort of specific advanced materials, compound semiconductors, advanced packaging, photonics, and especially those really interesting links to other emerging technologies, other critical technologies like our future of compute, like quantum computing. Semiconductors are key. I don't need to tell you that, you will all understand that, but it is just fascinating when you think about it. And sometimes it's hard to tell that story of how important semiconductors are, because it's sort of like, it's in everything. All of your phones have it. We have it on us right now. And you know, in the future there will be even more of them, and how many are going into electric vehicles, how many semiconductors will be in automated vehicles. So it's sometimes quite hard to tell the story, but when you think about how the new government had set itself the 5 missions, that's economic growth, net zero, opportunities, which is all about skills, health, of course, and safer streets. There's a role for semiconductors in all of these, and actually innovation and solving some of the really big challenges this country has and faces right now can be addressed with semiconductor innovation. And that is quite exciting. That's exciting for government, and actually thinking about it much more as an enabler, not just thinking about it as one sector where we have some strength and, you know, those are really fantastic, we want to support them, but actually starting to think about it as an enabler of growth in a lot of different sectors, and where we can draw those links and the innovation and research and development that we're having in this country, which are excellent, into commercialization and making really exciting things happen, which I think we will touch on a couple of those areas later, so I'll keep you hanging there.
Okay, good afternoon, everyone. My name's Drew Nelson. I've been involved in the compound semiconductor industry since I was about that high. I studied at Sheffield University, and we created the first centralized facility for providing other universities in the UK with compound semiconductors. And at that time, we were working on these little chips, or little pieces of semiconductor, which is about 3 millimeters square, because they were so expensive. But I learned my trade at British Telecom Research Labs, did a lot of research into the future of fiber optics and the lasers and detectors that now enable the global internet to function. I co-founded a company called IQE and built it up into the world's largest supplier of compound semiconductor wafers, headquarters based in Wales, but we have manufacturing around the world. I stepped down as CEO about 3 years ago, and I've been involved in setting up a cluster in South Wales, compound semi-cluster, the first end-to-end cluster in the world, which Andy's been a big part of as well through the catapult. And more latterly, I've been instrumental in setting up some venture capital angel investing to try and help companies spin out of the cluster, and the universities that have been built around the cluster, particularly Cardiff University and Swansea University. So long history in compound semiconductors. So you might guess I'm a strong proponent of that particular sector of the industry. The question though is why is the supply chain so complex? It's so complex because making semiconductors is so complex. When you look at all of the different steps that need to go to come up with a finished device, it's incredible. All the chemicals that go into that, all the processes to grow the substrates, to grow the epi, to then process, we've got technologies now that go down to 2 nanometers, which is only a few angstroms. It's just incredible to think about. And then you've got packaging, you've got reliability testing, you've got a whole host of things that go into it. So that's, I think, the fundamental reason why the supply chain is so complex. Where does the UK play in this? Well, we've got some real strength, I think, which we've talked about on the panel a little earlier, particularly in design, particularly in compound semiconductors. But we have little pockets of strength in other areas as well. The UK is very good on equipment manufacturing, for instance. We have a number of companies who are absolute world leaders in process equipment. And so I think we need to work together very closely to build on our strengths, build relationships with other countries that have technologies that we don't have ourselves so that we can access them and at least have some security of supply in the future. So that's one of the big functions, I think, of the semiconductor strategy as it evolves over the next few months.
There's a lot we can unpick there, right? Thank you all for getting us started. Okay, there was a few points there. So we talked a lot about why the supply chain is so complex. We talked about where the UK has expertise, but also why we can't necessarily view semiconductors just as a technology. They need to be viewed as the horizontal as well. And so there's a few points that I want to maybe dive a little bit deeper into, and I want to start with that one. So semiconductors require their own policy as a technology vertical, but they also need to be viewed as this foundational technology powering some of the key industries. Do you have any examples or anything that you want to build out on upon that point, which really showcases why we need to view semiconductors in that horizontal? Peter, I'll go to you first.
Sure. Well, I mean, yes, I think as I think Eva and others are talking about, like semiconductors are fundamentally ubiquitous across every form of life. I think we say that 99% of the world's smartphones have an ARM-based chip in them, but then also sort of on a daily basis, most people will engage with, however, the order of magnitude of these chips in whatever form they be. And I think there's the consumer products, which I think people are now starting to understand a bit more. And Andy was talking about the kind of the variety of chips within your smartphone. But then, in terms of as we start to see more elements of our life becoming more connected with the internet, the average home, I think, has about 10 internet-connected devices. And I think it's one of those things, if you think about it, actually, your TV and, your doorbell and all these other things, like we're starting to see that happening much more often. But then also, data centers, all of these kind of things are things that we don't necessarily think about on a daily basis, but actually the infrastructure that underpins our life, so much of this is obviously all embedded across all the semiconductors, which are the foundational element to that. So, I think it's one of those sort of, it also, unless you're really into it, you can't go and buy a semiconductor, but you can buy products that are associated with them. So like you kind of forget that they're there. And so I think that's one of those things, is the level to which they are sort of so foundational, but then also, and I think this is the question we sometimes face, is that they are so foundational, but also it's quite hard to really get that kind of breakthrough into sort of the living rooms, people talking about semiconductors and compound semiconductors. We're still not quite there. We're trying, but to try and think about how can we get people talking about at the breakfast room table. I think that's we're quite away from that. But so then, how do we focus politicians? How do we focus those to think about where the areas of strength are? And I think DCIT's doing great work to try and focus on those foundational, key areas of strength, because I think otherwise you can get quite waylaid by saying, we want to have this one area here. So.
Yeah, thanks. I think it is important to think about both the horizontals and the verticals. There was a very influential report published earlier this year by Perspective Economics, funded through DCIT, that looked about where the UK played in the semiconductor supply chain. Now, interestingly enough, when you look at a semiconductor supply chain, the value increases typically by 5x or 10x from one stage to the next, and there's typically about 5 stages in the supply chain. Now, if you just look at the horizontals, if you just look at the base of manufacturing the semiconductors on their own, then that in itself is a high value added activity. But when you look at how they service some of those verticals, that is where you get capture the real value. Now, it's fair to say, to Peter's point, it's fair to say that we don't don't make, in the UK, we don't make all of the verticals. So we don't make the complete stack for consumer products, but for other products we do. We're very active in electric vehicles where the margins are higher, so we have a large proportion of the stack in electric vehicles. We heard earlier from one of the defence primes, and again, in those particular markets, very, very high added value. So the more of that supply chain you capture, the more value you're capturing in the UK.
Fantastic. Eva, I've got 2 questions for you.
I'm pleased that nobody stole my thunder. Yeah, so I was thinking about the different areas and you know, as we said, it's sort of, you can pick anything, you can just throw a ball in the room and you will find something. And the area that I get very excited about is net zero. And this is, as I was just saying earlier, is one of the growth missions, one of the 5 missions of government. It's also one of the 3 pillars of the industrial strategy as set out in the Green Paper recently. And I think sometimes because we use examples like it's in your phone and people understand that, they know what a computer chip is, they know it's on their bank card. We sometimes forget that actually semiconductors play a role much more widely than the sort of more tech devices that we're thinking about. And especially when you think about net zero, yes, they will go into future electric vehicles, and it's just incredible numbers of how many chips we are expecting to go into electric vehicles and autonomous vehicles in the future, and they play a role within that, but also how you enable smarter grids, how you enable renewable energies, technologies to be connected to the grid, and power electronics within that compound semiconductors within that is actually really fascinating, and there's obviously that other aspect of semiconductors within the power distribution side of the sector. And I think that's quite exciting actually, because I can hardly imagine a future in which we are going to transition to net zero that doesn't involve semiconductor innovation. So this is for me one of those areas where we have strength. The UK is incredibly strong in R&D, but also in the manufacturing side, and actually commercializing that and making that a bigger story and translating that into something that can really benefit us all. And there's a very different impact to kind of us being able to use the latest AI on our phone, thinking back to the previous panel.
Do you think that's clear though? Do you think it's clear in the Industrial Strategy Green Paper how integral semiconductors are? Or maybe to rephrase that in a way that's probably a bit more answerable, what can we as industry do to emphasise how important semiconductors are for the industrial strategy?
I mean, that feels like a really nice segue into kind of encouraging all of you to contribute to the industrial strategy. I don't think the Green Paper is quite at that level of detail just yet. We launched it a couple of weeks ago, and there is a window of time now to contribute to the open consultation, so anybody, all of you individually, have the opportunity to feed into the Green Paper. There's a lot of work happening, as you can imagine, within government at the moment to exactly answer these questions on what are the key enablers, what are the critical technologies. And I don't want to spoil it too much, but semiconductors is coming out as a really strong enabling technology, not just for, I mentioned net zero, and not just for the obvious areas of digital technologies, but also actually across all the different sectors that were identified, from automotive to advanced manufacturing. You name it, it's very hard to think of a sector that isn't substantially enabled by semiconductor innovation. So there's an opportunity, but as other panelists were saying, it's not necessarily very obvious. Not every other end sector and company kind of working at the end of the supply chain will be thinking about semiconductors and how dependent they are. That's exactly why we're in the situation where governments are throwing a lot of money at the challenge of some semiconductor supply chain resilience. Therefore, I think it's really important to have this voice within the consultation, and really important to bring it out within the industrial strategy, which will be published later next year. So you have an opportunity to influence, and while there's definitely a lot of pockets in government that understand the relationship, we need to hear from you, and our understanding will always be second to yours in making these links.
Great point on resilience there. We'll definitely come to that. Sorry, Peter, did you want to come in?
Yeah, no, I think that the Green Paper did show that there is sort of ambition to focus on the areas of technology where the UK has strength. I think from our side, I think it was we think there could be a much more focus on the importance of semiconductors. How can we make sure that we are advocating more across the various components of the supply chain? And I think to Andy's point, he was saying about the level of speciality. I think also thinking of semiconductors as one thing is actually a bit of a problem, because actually the level of speciality and also the policy intervention and what is needed in terms of the partnership with government to unlock that level of growth is incredibly different depending on what part of the supply chain you're working with. So, what ARM really sort of looks to and what the design infrastructure around Cambridge, and it's not just ARM, but all of the other design companies that have a base in Cambridge, is really around kind of access to talent, and it's access to making sure we have the most effective computer engineers on the planet coming to Cambridge. And that's a skills problem, that's an immigration problem. And then there's questions around how can we focus on the level of speciality with regards to sort of trade and the importance of how can we make sure that ARM is a global company, our partners are global, so how can we make sure we're engaging with companies where there's a huge relationship, which we can really kind of update our relationship on those challenges. So I think about India, and the UK-India relationship is incredibly important there. So again, I think these are things which hopefully, I appreciate there's a kind of ongoing process, but there's a lot of stuff we can really draw on there. It's great to see that the UK is and the semiconductor team is really looking into this, and the strategy is well on that. But I think how do they fit together? There's still a bit more to do. So yeah.
So how an IP company doesn't necessarily have the same policy interventions that a compound semiconductor company would need. Yeah. So the points there around international partnerships and resilience we're definitely going to get to in just a second. But I think the one aspect, just before we move on, that we haven't quite teased out here is that we have some fantastic semiconductor companies such as ARM in the UK. But there's a long line of scale-ups and startups in this space that also need targeted and tailored support. And quite a lot of them are also around the Welsh Compound Semiconductor Cluster as well. So to Andy and then also to Drew, how can we better support our scaling semiconductor industry? Do you want to get us started?
Absolutely. So today, Silicon Catalyst has published a semiconductor policy paper. There's several copies out in the foyer. It makes 3 recommendations, very top-level recommendations. Create a National Semiconductor Institute. This was something that was in the strategy last year. Transform the funding ecosystem and launch a skills initiative. So there's sort of 3 sort of broad policy interventions that we think are critical. And the reason for that, so let me sort of back the truck up and sort of describe the reasoning for it. So Silicon Catalyst is working with a cohort of semiconductor startups. Last year we had 11 startups. This year, I think we've got 10 or 11 again this year. When the program was launched, this is actually very generously supported by Ava's team at DCIT. When the program was launched in October last year, I naturally thought, chip start, this is all going to be people designing microprocessors. It's all going to be silicon design. And surprisingly, about 7 of the first cohort were compound semiconductor design companies. So actually what it's doing is it's tapping into where the UK really has strengths. And these are companies coming out of the research base. Brilliant ideas, developing compound semiconductor materials, photonic integrated circuits. In the second cohort, we've got a company which is doing EDA tools. Now, an EDA tool is how you actually design, how you actually go back to the physics of designing the actual semiconductor itself. So a fantastic program, really high value. In the first cohort, we've actually realized a 20x, we crowded in 20x investment into that cohort. So it's a really fantastic thing. The challenges that these companies, and historically the UK has produced 16 unicorns, semiconductor companies valued at over £1 billion. The challenges that these companies are facing in order to get further on is those 3 things. It's access to funding, VCs. Great to hear that Drew is working on a VC angel investment. That's really what's going to fuel those companies to take it further. The skills initiative is that they're quite often short of skills in order to grow. And the National Semiconductor Institute is just really kind of recognising the fact that it's a complex ecosystem, it's a complex landscape, lots of different types of semiconductors, lots of different moving parts, and it's really there's something to coordinate.
Yeah, thanks. Big question. Perhaps I could just make a comment on the previous question as well.
Of course, yeah.
So on the green paper that was published by the government, I was really disappointed that semiconductors weren't higher in the pecking order, as they say. Semiconductors in that 76-page document were mentioned once, one single mention. And semiconductors, to my mind, underpin everything. All the 8 growth sectors are completely dependent upon semiconductors and semiconductor technology, and it must be a key priority of the government to prioritize it as a subsector for support as if it were a vertical. You cannot imagine any of those, like the digital, for instance, existing without semiconductor technology, fundamental semiconductor technology. And the UK's got a lot of different, to the point you're just making, a lot of different entities which can contribute very strongly to this. manufacturing was one of the huge areas that I thought was missed from the National Semiconductor Strategy. And when you look at the companies we have around the UK, from KLA manufacturing equipment, Vishay manufacturing silicon carbide and gallium nitride, Seagate in Northern Ireland, IQE, Lumentum in Northamptonshire. There's a whole variety of pretty large manufacturers that support some fundamental semiconductor technologies in the UK. And of course, we got the startup entities, and ChipStart, I think, is a great program. It needs a lot of fostering, and of course, the companies that come out of that will need a lot of support as they grow into Series A and Series B and Series D. But manufacturing is also a critical economic driver within the UK. And so if we take the South Wales cluster, for instance, there are now about 3,000 employees in that cluster. The GVA is between 2 and 3 times the national average. The average salary is about twice the national average. So these are really high-paid, highly skilled jobs. And to the point about skills, where skills come from is not only the pipeline from schools to universities and everything else. It comes from people being employed by these companies and employing apprentices, but also just retraining people from different industries to enable their skills to be used in the semiconductor industry, because there's a lot of cross-fertilization, if you like. So Port Talbot's a good example, where there's a lot of steel workers being made redundant, but a lot of skills there can be redeployed in that area. So to your point about the UK and the different companies, we have a myriad of different companies across the entire spectrum of the technology, but also in terms of different sizes, from startups right through to significant manufacturers.
Fantastic. I'm aware that we're jumping around a little bit, but skills, that's come up a few times now, so let's dive into that a little bit more. We're aware that talent is one of the biggest challenges facing the semiconductor sector, whether you're working in design or whether you're working in compound. Broad question, but how do we go about addressing this shortage of skills? Peter, I'll go to you first, but really eager to hear everyone's opinion.
Yeah, I think in the immediate, the problem with skills is I think there's a huge spectrum of what part of the supply chain we're talking about, and the requirements you have. So whether it's material science for compound or electrical engineering for more the design side, the requirements you have are very different. The way that I think I frame it from an ARM and design electrical engineering perspective is there's 2 issues. The first thing is I think we don't have, for whatever reason, the broad talent pool working its way up the education sort of from primary school up. And so the question is, how can we make sure that the applications of semiconductors, the importance of electrical engineering, how are we broadening that interest so that particularly more girls, more sort of broader population groups are kind of having an interest in science and technology and physics and working their way up, so that by the time they get to university, they are sort of thinking about, if they want to study computer science, electrical engineering, whatever engineering it is. The second problem is that at the moment what we've got is if you're a computer scientist or have an interest in computer science right now, and you're 18 years old and you're thinking about what to study at university, what is being discussed in the breakfast room table is AI and machine learning and large language models. So they're going to think, let's go and, if you're very, very clever and you've got these amazing qualifications, you will then go and want to study an area in that field. And I think the problem that you've got is that we're not seeing the level of interest going into computer architecture and electrical engineering, when actually, it's thinking about how can we break down the supply chain to demystify it so people can understand this is an area where the UK has incredible strength, and we can start to focus our energy. So there's 2 kind of issues, and about how can we sort of starting earlier on. And I think there is a huge potential there. Think about Skills England, you think about the work that's happening to try and sort of, there's already stuff, you can talk about the experience of cyber broadening awareness games like Cyber First. How can we sort of leverage some of that success? Something else to think about as well is what we've got at the moment is there is a huge amount of talent that's currently coming out of other parts of the world. So particularly India, huge numbers of electrical engineering, huge numbers of graduates in that area. And something that I'm interested in is at the moment, if you look at sort of the electrical engineering, computer science sort of graduation cohort in the UK, it's about 80% men, 20% women. And I think if you go to India, it's more like 50-50. And there's questions about what can we learn from that? How can we sort of think about broadening that perspective? So, I think there's a huge amount we can do there. ARM has, as a founding member of something called the Semiconductor Education Alliance, which looks at sort of broadening, trying to build partnerships with other semiconductor companies to try and think of how can we engage with this a bit more. And we also try to define the knowledge, skills, and attributes that we're looking for so that it's easier for someone to enter the job market. And whether that's someone, and again, to Drew's point, I'm thinking more about people kind of coming up into that level of specialism. But there are people at ARM where probably a retraining or something which is more an apprenticeship model is also a viable option. So how can we make sure that we're championing that? But I think there is, for me, a fundamental problem about demystification, because I think semiconductors is sort of assumed, but actually it's not really understood. And I think we can do more to champion that more.
So I think all of the panel were nodding along with you in agreement there. But Eva, do you want to build on that?
Yeah, I don't think I've ever had a conversation about skills in semiconductors and had a disagreement with anybody, because we all agree they're not enough. I had a similar stat to kind of the 80-20%, and I was looking around the room, and I think the room represents the semiconductor industry pretty well in terms of gender inequality, and it's also something our minister's really picked up on as he was engaging with the sector. It's something that is not particularly unique to the semiconductor sector. It's across a number of different tech sectors, and working in cybersecurity early in my career, it was exactly like that. So it's not a unique challenge, but I agree there is something about demystifying it. And when you visit fabs, I think sometimes also when we hear a factory, I think we're thinking sort of dirty, and couldn't be further away from the truth in any sort of semiconductor fab. So that's also an interesting one, getting people more out there and understanding how it's all working.
But also, it's not just fabs. I think you don't need to wear a hard hat to visit, to be involved in semiconductor ecosystem. I think there's a, ARM. I think I've been saying we need to get some ARM hard hats so people can come and visit our office a bit more, because there is a challenge about with these kind of organisations when you don't have that.
I'm not sure how many people are wearing hard hats in the semiconductor industry, though. I was thinking more of a full suit. No, absolutely right. And I think the range of jobs, and one of the things that struck me, especially with the Chip Start program that Andy was talking about, I think coming into this, I was also thinking a little bit more about, okay, so how do we help these companies really develop their products and their services and make sure that they're ready for market? It's not actually that. Actually, sometimes the skills are something that you wouldn't necessarily think of, and that's more the business skills, because these are people that are passionate about technology, people that are really have a deep understanding of very technical issues, but they don't necessarily know how to talk to an investor and how to sell it to somebody that doesn't understand semiconductors, that isn't really into deep tech. And helping companies to do that, and helping people understand that there are other jobs out there too in this space, whether there's business managers and technicians also. We're thinking often about engineers and PhD students, but actually thinking about the full range of jobs that are out there. It's a little bit daunting, because we're sort of facing shortages across all of this, and where government intervention is best placed is sort of the question that we are trying to answer. And you will be pleased to hear, in the very first meeting last year of the Semiconductor Advisory Panel, we went around the room and the co-chairs gave everybody opportunity to raise two issues that are the top priorities, and across the board, skills was part of the top two for every single member of the advisory panel. So we understand that this is the area where it's probably not going to be enough to just have industry drive it. We know government has to also step in and do our parts. Stole a lot of my thunder there, learning from what's already worked. Cyber First is a really good example of where we've seen success of getting more women into the sector, of getting more ethnical diversity into the sector as well. So we're trying to build on that, see whether we can replicate similar successes, looking at bursary schemes, looking at apprenticeship schemes. But all of that is obviously looking at a much longer pipeline. So I thought your point on upskilling and actually thinking about retraining is so important. Industry having great initiatives, and we're just trying to build on that. But just going back to the point on, we can't just all do it within the UK, and a lot of the talent doesn't come from the UK. We recognise that, and making sure that we have partnerships. Actually, right now this is slightly different, but part of my team is out there at the moment in the Netherlands in an exchange between a number of different companies and researchers and academics that are learning about the Dutch environment and trying to create collaboration, which might translate into also skills collaboration. We have partnerships with a number of countries in Asia, including also Korea, Japan, but the same in Europe and the US, and making sure that we can solve that problem together, because actually, funny enough, despite this conversation we're having and all of us nodding rigorously, when I talk to international companies and we have meetings with big companies like Intel, the reason these companies come to the UK and why does IMEC come to the UK is the skills and the talent pool. So ironically, even though we say we're missing all of these talented people to come into the sector, this is really our strength. So we are at risk of losing pretty much crown jewels of what we have in this country and that are fueling all of these strengths that we talked about. So we take that very seriously, and we definitely can't do it alone as government, and it needs that cross-sector effort.
Okay, so I've got 2 points that I want to ask around the domestic industry before we get to that point on international partnerships. And I'm very acutely aware we're already starting to run out of time. And I do want to come to the audience to start thinking if you do have any semiconductor-based questions you want to ask. But I think 2 points that we just need to tease out a little bit more before we move on. The first one is we've had the mention of a National Semiconductor Institute on this panel. I think maybe for the audience, we need to just clarify what that is and what role it could play. So Andy, I'll come to you on that point.
Sure. So I think what's been happening globally, so the US, they have the US CHIPS Act. It's got $52 billion of money behind it, but also as a central coordination body. And that acts as a central coordination. So in other words, the rest of the world knows where to go. It sets the direction of travel for the US. In the EU, there isn't not quite such a centralized body, but there's a higher degree of centralization. And I think where we are with the UK, as we've discussed earlier, preeminent in terms of universities, as Lord Valence was saying, for the top 10 universities. So the research base extremely good. In the materials, compound semiconductors extremely good, and the designs extremely good. So it's quite complex. So it needs that sort of central coordination body. And it will also act as an attractor to inward investment. Now, the other point I was going to make, and I think this kind of reflects on some of the thoughts about the industrial strategy, is semiconductors are not a short-term bet. What we need is something which is going to take a long-term view. It needs to look at design, IP, manufacturing on a 10-year time horizon. So the organisations that will be working with, things like UKRI, Innovate UK, etc., Electronic Skills Foundation, it needs to take that sort of 10-year time horizon, investment appetite, 10-year time horizon. So I think that's the central role of what it ought to be doing. And there are, just to finish off this last point, there are some kind of precedent. So there's the Aerospace Technology Institute, the Advanced Propulsion Centre. They have generally had 10-year remits as well, and they've been very successful in being able to do that.
Makes me think a little bit about the National Quantum Technologies Programme as well.
Exactly, yes.
Building on that, Drew, I want to come to you, see if you have anything you want to add on the National Semiconductor Institute, but I just want to give you the opportunity to come back on an earlier point that you made, which was, is there any targeted infrastructure spending that we could make in the UK to really build on our semiconductor strengths?
Let me take the National Semiconductor Institute first. I think it's absolutely essential that we have something like that, a coordinating body. As Andy mentioned, in the US, they've got the Semiconductor Industry Association, which really takes all the inputs from the semiconductor industry there, from academia, from industry, and really coordinates that and positions it with government. And they were the fundamental reason why the CHIPS Act was so successful in leveraging whatever it was, $52 billion of investment. You know, they made the point very clearly. They set out in a number of publications that the impact of the semiconductor industry in the US creates, I think it's 6-fold increase in jobs for every direct job in the semiconductor industry. So the economic impact is absolutely huge. The National Semiconductor Institute here, I think, needs to be built on similar lines, taking all the inputs from industry and academia and other entities within the UK, and coordinating them and giving them some real clarity to government. And if it's properly staffed by long-term industry people who really understand the fundamentals of it, then I think it can have a very powerful role to play. It will direct inward investment and be a landing point for international partners. And it will address one of the fundamental problems that I have, notwithstanding you hear from DCIT, but one of the problems with DCIT has been the high turnover of personnel and the lack of a fundamental understanding of the semiconductor industry. So there's not a lot of domain expertise. There are examples, some other examples, but fundamentally it happens because there are very talented, very bright young people who come into these roles within, let's say, the semiconductor team within DCIT, but they're career civil servants, and so they want to have a career, which means they move on every 6 months. And if you look at the turnover within the DCIT semiconductor team, since the semiconductor strategy was announced to be developed, I think every single person's changed seats perhaps 3 or 4 times, including the ministers. So it's not a criticism of anybody in particular, it's just the system. And so the National Semiconductor Institute, I think, will solve a major problem of having real expertise, looking at a 10-year time horizon and taking all the views of industry. In terms of the second question, which was, do we need specific interventions? Yeah, I think we do. We need to look at the gaps in what we have within the UK. Open access foundries, I think, is one of them, because a lot of our startups, chip designers, they end up having to go to Taiwan or somewhere in Europe or even China to get some of their stuff made, which is not great, because in terms of their own development and security of supply, then there's a big challenge. And so I think we need to look very carefully at what's been missing. There was a big study done by the Institute for Manufacturing as part of the DCIT team. I would love to see that more widely published. I know some aspects of it have been published, but it was a big body of work. There's a lot of consultation, and I would like to see that more widely distributed if possible. So there's a plea to somebody.
And I guess context for the audience, that is also what the National Semiconductor Institute kind of came out of as well. Okay, we got there. We got there to international now. But I think setting that discussion around where our domestic capabilities lie was really important. Okay, so this conversation has clearly shown that we have UK capability, but we cannot lead on anything. There are natural partnerships that we're going to want to grow internationally to support UK businesses, but not sure if, based on this conversation today, we're necessarily getting it right. So what targeted interventions do we want to see on that international scale? Shall we? I think everyone might have an opinion on this, so if I go this way. So Andy, to you.
First.
Yeah.
Sure, it is an international market, and it's a global market in terms of selling the products. In terms of developing, designing, it's an international market. In terms of selling the products, it's an international market. Some countries have, I think when choosing international partners, you need to look for reciprocal arrangements whereby the UK benefits from the relationship and the other partner benefits from the relationship. I'm very well connected into the Far East, into Taiwan and some of the other countries around that region, and India. And I think there's a perception that the UK, well, not a perception, they actually consider the UK to be the design factory. And they've openly said that. We are the design factory. We come up with the brilliant ideas, we design stuff, and there's a kind of a perception that we design and somebody else is going to make. Now, that might work for some things, but I don't think it's a model that fits everything. So certainly in silicon small node CMOS, that model works extremely well. I think for other materials, it's not the right model. And we need to think about how we retain things in the UK. We need to think about being very robust about defending our IP. So if we are having international relationships, we need to think very carefully about defending IP. Some of the countries, so somebody did mention India, they're investing $10 billion in doing semiconductor fabrication, which is a very ambitious program because of their infrastructure is slightly behind where some of the other countries are. So that's going to be quite a challenge. So that could be an opportunity for us to help and do some technology transfer, maintaining that we protect our IP. But again, they have their policy is made in India. So they actually have a policy of, we want to bring this onshore for a very good reason. It's a made in India policy. So I just think we need to be forming these relationships is very important. We need to be very cognizant about how we defend our own model. Now, the last thing I'll just kind of round off on that. Innovate UK have run a GBIP, a Global Business Innovation Programme. They've done bilateral funds to look at international collaborations on an industry level, industry to industry level. I think they're extremely good at testing out where those relationships work, because it was a greenfield site when they started to launch that, and it's testing out how those collaborations will work and where the value is. We can go back and look at some of those projects and programs and use that as the sort of the mechanism and the framework to establish more firmer international partnerships.
Does anyone else want to come in? Because I'm very acutely aware that I want to give the audience time for questions as well. So does anyone else want to come in on international?
Well, I completely agree with what Andy was saying about the importance of making sure that it is sort of front and centre. I think what I hear is that I think we do find ourselves finding the challenges of, it is a global ecosystem. We need to make sure we have those strong partnerships where we have the customers, and whether that's West Coast of the United States, or the Far East, or India, where India is the home of ARM's second largest site. I'm in Bangalore. I think there's a challenge, and I think this builds a little bit on what Drew was saying about kind of how does government look at semiconductors, how does it look at the importance of that and the growth in that value? And I think some of the agreements that we have in terms of trade agreements or in terms of international agreements with other countries are based on a world when the UK made stuff and exported the physical product. And actually thinking about the importance of IP and these areas, I think actually there is an opportunity to improve it, to make it easier for those partnerships to work more easily. And I think again, I think there's the question about the infrastructure, the institute. A challenge we have is how do we focus energies in the right place? And I think things like the SAA do a really good job in the United States. And you talked about the Perspective Economics paper as well, which have helped to clarify sort of where we think some of that the value is in the UK. I do think if we look at like industry classification codes, like SIC codes, I think they don't capture the ability they don't really capture the nuance of the reality of the new economy. So like ARM's business doesn't naturally fit into a SIC code, even though if you're a shepherd or a goat herd, it would. And I think this is a sort of there are various classifications of how do you actually clarify what those things are. So how can we support government to make sure that it is sort of really capturing the reality of what an economy looks like? I think that will really help.
I'm just going to pause. Are there any audience questions based on the conversation? It's fine if not. Got a question here at the front.
I just want to ask the question with that bugbear in the room about skills being a major form of inertia in development of the semiconductor industry. If you look across all the different vertical and horizontal layers that might actually span across, are there some common themes that can be learnt by people at earliest age possible and simply refined over time through university up through into the workplace? What's the earliest things people can start with?
So I actually used to be a teacher many years ago. So into it. So I think the way, if you look at the way that science is educated, I think that there's a very antiquated view about sort of you go principles first, and I think actually more of an application first approach of saying, look at these amazing ways of using technology. These are ways that we can work with it. And in cybersecurity, I can guarantee that in the school I teach in Brixton, if I was to say, here is a piece of technology, I will incentivize you to please break it. That would be incredibly attractive to any sort of 14-year-old who says, hey, I want to break technology. Like penetration testing is a really great way to get people to engage technology, to think about the applications of these things. And I think that there is now a new opportunity, because I think that of course education is one of those political sort of pendulum swings in terms of sort of knowledge and sort of skills, and then applications, and I think there is that sense of, as we see a new administration thinking about it, it'd be interesting to see like how curriculum design can be sort of updated, if that's an opportunity. I think something that I am interested in is the relationship with the new DCIT, because I never worked for DCIT, I worked for DCMS before it was created, but is the relationship between DFE and DCIT in terms of skills. And I think the kind of, whether it's extracurricular and curricular, and how do they work together, and how can industry better promote sort of initiatives that we've done, whether it's through sort of school engagement programs to say like, how can we broaden that talent pool so more people at a younger age are getting really involved in it. I think I'm always interested in that.
Fantastic. We probably have time for one more question if there is any. Yeah.
Some comments more than question. In the Netherlands, I was in the Netherlands, part of the Photon Delta ecosystem. So photonics is a CAT, key enabling technology, recognized, funded over a 10-year period. So I think we're missing a trick here about not defining what are foundational technologies, such as semiconductors, which are in everything, and transformational. We had a lot of sessions today about AI. AI will be transformational. Even in industrial strategy, semiconductors, as Drew said, was mentioned only once, maybe. Quantum was mentioned, I think, 3 times. So that brings me to the skills question. I think one way, we hear a lot of vagaries about skills, we're boiling the ocean, but maybe we need to look at it in a different way. What is this skills strategy for scale up. If we want to, be leaders in transformational technologies such as AI, neuromorphics, what is the type of skills we need to scale up? So where does this bring the semicon sort of education system and so forth? We can't compete in just boiling the ocean, bringing more sort of a leaky pipe type approach. So I think that world is very complicated. It's already hard. Semiconductors is hard. Next year I'll have spent 30 years in semiconductors. I've designed systems, deposited, grown, etched, survived 5 or 6 waves. Drew knows it, from the photonics to the MEMS, ultra-bright LEDs, with the AI wave. Somebody was saying there's going to be a telecoms wave. It hasn't happened yet. So I think it's all about trying to make sure semiconductors are foundational. Where do we want to play? Do we want to play in quantum space? Or we want to play in the AI space? What sort of skills will get us there so that we can be leaders? At the moment, that isn't the case. So we can't just say we need more material scientists. Of course, we need them. But semiconductors is an export business. We export. So we need to be able to recognize that as well.
Does anyone want to respond to that?
Yeah, I wonder if I can just say a couple of words. I mean, on the whole skills front, we've talked about education, and that's correct. And awareness, I think, is a very powerful thing. But it's education across the entire population, not just early age school kids and things like that, because the parents, careers advisors, teachers, whoever it is in the communities, can make an impact on what a young person decides to do, or anybody else who are wanting to change careers can do. And so I think a national awareness campaign and education about what the opportunities are and what the power of semiconductors are, I think would be a great thing. So I would encourage everybody to contribute to this green paper and put semiconductors right up the top in terms of this foundational technology. One of my other roles is I'm chairman of the all-party parliamentary group for semiconductors, and one of our core themes there is to get parliamentarians to understand what semiconductors are. And so getting Parliament as a whole, I think there's a tremendous weakness in understanding of what semiconductor technology is all about, even though...
I couldn't agree more on the demystification challenge, but how can we, what more can we do to support awareness levels of, I think parliamentarians are always predisposed to not ask some of those fundamental basic questions because, no one wants to be that senator who asks Zuckerberg, how do you make money? Because, everyone just laughs at you. And I think the question is, how can we, in a safe space, engage with parliamentarians, engage them to understand this area? And so, I couldn't agree more with that. And I think that to the point also about the Institute as well, there's a question about if the challenge about funding, maybe there's also a question about for VC as well, how can we be supporting that? And it's something that I hear about, a challenge for growth is levels of understanding in VCs as well. So I completely agree. And to everyone, please make sure that we'll feedback to the green paper, semiconductors is at the top. That would be great appreciated.
I'm really sorry, I am going to have to cut us off because we are at time. So what I'm very quickly going to ask the panelists to do is, what is the final comment you would like to leave the audience with? And if you can put it into a sentence, that would be great. Andy, I'm sorry to pick on you again, but you're right next to me, so I'm going to go this way.
Okay, final comment. The biggest challenge in the AI space I see is the energy consumption of AI, so we have to massively tackle that. That's going to require new microprocessor architectures, but it's also going to require new technologies like photonic integrated circuits and analog compute. If I can leave it at that.
Fantastic.
Cool. So I would say that semiconductors are very complicated, but they're fundamentally that they are a people-based business. So I think the skills, the importance of the talent, the importance of people, I think it's very, it's important to really focus on that. I think the UK does have incredible history in this area. In the last 30 years, ARM now has got to a point where it is in every single smartphone pretty much in the world. And I think that, we have got some real sort of legacy to build on. And I think that, we just need to make sure that we're focusing on that. But let's not forget that it is fundamentally about the people who work in it.
I like that. 2 points. One is about more coordination in the sector. We were talking about the Institute earlier. we've talked about the diversified supply chain, how diversified the strengths are within the UK. We need to see more coordination. Government is trying its best, and we're looking at other measures to enhance this coordination. But we can only solve this and only tackle this, especially kind of not being maybe one of the largest players in the world, by working together. And a good opportunity to raise a lot of the points that have been raised on the panel and in the discussion is the industrial strategy. You've made my job for me. The consultation is open until the 24th of November. You have a window of opportunity. If you don't have the link, let me know, and I'll take your card and I'll send it to you. And we will look forward to hearing from you.
Lobby like crazy to make sure semiconductors are at the top of the subsector list in the new industrial strategy.
Should work for government.
And I think that rounds up this panel really nicely. So everyone, round of applause for our speakers.